solving systems of linear and quadratic functions. So what we notice in problem number 2, we have a linear function and we have a quadratic function. And so we are going to solve by setting those two equal to each other, and then we're going to graph to verify that we have the correct solution. So I'm going to begin by setting x squared minus 3x plus 1 equal to x minus 3. And so I'm going to subtract x from both sides. And then I'm going to add 3 to both sides. I'm going to factor x squared minus 4x plus 4 to find the solutions or roots. Therefore, x is equal to 2. I need to go back up to one of my equations, either one, and replace x with 2. And I'm going to select this bottom equation, and I'm going to replace my value for x with the number 2. So y is equal to -1. So my solution set is x, comma, y, or 2 comma -1. To verify my graph and solution, I'm going to use Desmos. So I notice that my parabola and my line intersect in one point. And I notice that point of intersection is 2 comma -1. Number 4, again, I'm going to set both equations equal to one another. Since both equations are equal to y, then both of those must equal each other. So I'm going to begin by subtracting x squared. The reason why I'm going to subtract x squared is so that when I bring the x squared to the left and I subtract, I'm left with a positive x squared value. Makes it easier for factoring or completing the square or even using the quadratic formula. Now the next step, I'm going to subtract 5x and I'm going to add 6 in the same step. Subtracting 5x and adding 6. left side. Therefore, x is equal to 3. And this time I need to go back once again and either replace x in the top equation or the bottom equation to find my y partner value. And I'm going to select the bottom equation. So I'm going to replace x with 3. And then I'm going to check it and verify it with Desmos. So I'm looking to see if my solution set is 3 for x and 18 for y. 3, 18. And that appears to be correct if I look at my graph. If I go over to the right 3 and up 18, it looks like it's about right here. In this next problem, we're looking at a business situation where we are producing bicycles and we're given two different functions. The first function that we're given is our cost function. This is how much it costs to produce the bicycles, and x in this situation represents the number of bikes. We're also given the revenue function. That's the amount of income that the company makes on producing all of the bicycles. So costs and revenues. When our costs and our revenues are equal to each other, we call that the break-even point. When our cost equals our revenues. In other words, what we put out equals what we take in. When those are equal to each other, then we break even. So to begin, we need to calculate the cost of making 15 bicycles. So I'm going to use my function c of x. And since x represents the number of bikes, I'm going to take out x and replace it with the number 15. And that will help me to find the cost of making 15 bicycles. Same with part B. Instead of 15, I'm going to replace x with 60. To determine the break-even point, I'm going to set my cost function, which is 25x plus 900, equal to my revenue function, 100x minus x squared. And then I'm going to solve for x. And the reason why it doesn't look easy to me to factor is I would have to come up with two numbers that multiply to 900, but also add to negative 75. So I would imagine that most of you at this point would probably use the quadratic formula. All right, my value for B, negative 75. My value for A, 1. And my value for C is 900. So in part D it says, what are the solutions to the systems of equation? Well, we have two. What do they mean in terms of this problem? It means when I produce 60 bicycles or when I produce 15 bicycles at either number, I break even. In other words, I have no profit at 15 bicycles or at 60 bicycles. My costs and my revenues are equal to each other. We may need to graph this. Yes, we do. So let's take a look at what this looks like on a graph. So I'm going to go back and use Desmos, and I'm going to place each of these functions into the graph so that we can see where their break-even point is. Let's start with the cost function. And then my revenue function. And so where my two parabolas intersect, tells me that when I produce 15 bicycles, my cost, my linear function, the green line, and my parabola, the purple function, have the same revenue as they have cost, $1,275. At 60 bicycles, my revenues and my costs are the same, both revenue and cost being $2,400. So we call those the break even. The region between, see if I can sort of highlight that. The region in between here shows where my revenues are greater than my cost, and the regions below show me where my revenues are less than my cost.